Okay, so we'll start here. We talked earlier that matter has mass, takes up space, and the final thing is it has inertia. So this is a newer part of it. Just putting a little physics in there. Matter also consists of subatomic particles. Each has mass and size. As I mentioned in class, when you drill that down, you have protons, neutrons, electrons. When you drill that down, we believe that it's made up of quarks, and now we believe there's even something smaller than a quark. Again, items that we cannot necessarily see. A combination of these make up atoms. This is a reminder that you have levels of organization in science. We're going to be playing down here in this world with molecules and atoms, and in biology, you generally work with everything else here. We're humans. We like to have some kind of organization, or we're just organizing our thoughts. So, in this section, I'm asking students to compare and contrast and also define. I don't want a long definition, I want a workable definition. So when you see these words, I want you to know what it means. And so the first two that we compare are accuracy and precision. And accuracy, I'm going to call it bullseye. It means you hit the mark. Precision means that my measurements are close to each other. Now, I can be accurate but not precise. I can be precise and not accurate, or I can be both. The other thing that I like to mention to students, it seems to help, is if you have if you're playing darts and you hit right on the bullseye, you're accurate. And then if I'm over here and I keep hitting right here in this area, that's precision. There's another scenario where I'm both. I can hit around bullseye and be accurate and precise. Intensive, extensive properties. Intensive are independent upon the matter. And this is going to be density. This is going to be color. This is going to be your melting point. On the other hand, extensive is dependent. So this is going to be your mass. This is going to be the length. These are things you're going to measure. Physical-chemical properties. So physical, generally my students will say that they describe. Okay? They don't change. They do not change the composition. So if you change your shirt, that's a physical. That's physical. If you dissolve it in water and then you evaporate it back out, that's a physical property because it dissolves in water. You didn't change what you're working with. But if I take that same substance and I maybe stick it in fire and it burns, then that's going to be a chemical property. So a chemical relies on a chemical change. It's also going to be reactivity. So it's going to rely on changing your properties. Physical changes and chemical changes. Um, Physical, these are like your phase changes. It does not change what you're working with. And I'm referring to the chemical composition. So, dissolving, melting, etc. Then, if we have our chemical changes, you're going to have to change the chemical composition. So, reactivity with water. So, like group 1, sodium is very reactive in water. That's a chemical change. If I stick magnesium in a fire, that's a chemical change because I no longer have the magnesium I started with. I've now produced magnesium oxide. So changes in property, changes is referring to what the system's undergoing, and properties is referring more to a descriptive value. I have this graph here to help you a little bit with this. Properties of matter, are these properties determined without changing the identity of the substance? If it is yes, then that's a physical property. You're going this way. Does the property depend upon the amount of substance? If it does, then you go this way, and that's extensive property. If I'm going to go back up here to properties of matter, um, if I have to change the identity of the substance, then that's going to be a chemical property. And then I look at how does it change.